Alright, so today we're looking at geometric mean. And basically there's two diagrams you guys need to know for geometric mean. And two formulas. We're going to kind of give you a quick look at these, and we're going to practice a lot in class today. And then we'll have you guys actually working on the majority of this in class. So hopefully by 1 o'clock we'll be done with the notes, and see where we go from there. So some of these notes that already had to deal with the Pythagorean theorems, I cut out that information. We just went, we're only going to look at the geometric mean portion today. So first of all, we talk about the geometric mean. Okay, we're talking about, I want you guys to think about, when we think about mathematics, we say the mean between two numbers. What am I talking about? Not the sum. Average. You guys remember talking about mean, median, and mode? Okay, so the mean is the average. When we talk about the geometric mean, it's exactly that, it's the average. And it's not exactly that obvious, kind of what geometric mean represents, but it's really just the average between two numbers in a geometric sequence. And it's not really something that you guys have probably learned before. It's not something that's necessary in order to do this assignment, but it's kind of where that comes from. The formula is very simple. The geometric mean between two values is the square root of their product. And that you need to know. You need to know that the geometric mean between two values is the square root of their product. So we'll look at example 1. I need to find the geometric mean between 6 and 12. How do I set up the problem?
6 times 12, and then the square root of 6 times 12.
So the square root of 6 times 12. Okay, what's the square root of 6, or I guess rather, what is 6 times 12? 72. Is there a perfect square that divides evenly into 72? Really?
Yeah.
I can think of at least a couple. 90? 9 and 8. Okay. So if we go with the square root of 9, square root of 8. What's the square root of 9?
3.
Can the square root of 8 be broken down?
No.
The 4 and 2, so that's 3 times root 4, root 2. What's the square root of 4?
Yeah.
So what's 3 times 2? And therefore we get 6 radical 2 is our final answer. Okay, so that's going to be your geometric mean.
Are you going to have to work them backwards?
We need to work them backwards.
Like starting off with 6 radical 2 and getting 6 times?
No.
Okay.
All right, let's take a look at number 2. How do I find my geometric mean there? How do I set up the problem? So radical of 9 times 81. What's probably an easy way to do this problem right off the bat? What do you notice about 9 and 81? They're not just divisible by 9. They're perfect squares. So we can immediately separate them and get directly to our answer. The square root of 9 is 3. Square root of 81. 3 times 9. 27. Any questions on finding geometric mean? I will tell you guys that will be on your next test. Find the geometric mean between two numbers. Alright, so here's our big idea for today. We're going to use geometric mean, and this is something where you guys have already somewhat seen this on the last couple of homework assignments, and this will make your life a little bit easier. Notice that ABC, triangle ABC is a right triangle, where BD is my altitude. Anytime I have a right triangle with an altitude coming from the right angle, I can get a special relationship that's related to geometric mean. And so we get this really long sentence here. The measure of an altitude drawn from a right angle is the geometric mean of the two segments of the hypotenuse. Okay, so who's royally confused right now based on that verbiage? All right, I would agree. So the measure of an altitude drawn from the right angle is the geometric mean of the two segments of the hypotenuse. All right, let's try to piece this together as a single equation formula. What is my altitude? Who can name the altitude? No, not asking what is. I want to know what is the name. Based on that diagram that's given, what is the name of the altitude drawn from the right angle? So BD, all right? So what we're looking for there is BD. So the measure of my altitude, so the measure of BD is meaning equals the geometric mean of. So it means we're going to take the square root of a product. Now, what am I multiplying? The two segments of the hypotenuse. Well, if I look at BD, what two segments does BD create? I'm looking at my hypotenuse. Nope. I'm looking at the hypotenuse. So AD times DC. That's one of the formulas you guys need to have on your reference sheet. Okay, I would definitely copy down this model, and I would copy down that formula. So find an open spot on your reference sheet, add that in there. And we have one more we need to talk about. This one gets kind of great. On my next one, the measure of the leg of a right triangle is equal to the geometric mean between the hypotenuse and the segment of the hypotenuse adjacent to the leg. Again, you can catch all of that. One is we've said before in math, it is a foreign language, and it takes some time to read the language. Also in math, mathematicians are inherently lazy. We don't like putting fluff in any of our statements. We go right to it. So every single word that you see in a math textbook matters. It's the small details that make a big difference. So let's start off with this really simple idea. The measure of the leg. Okay, in this situation here, it's all going to be relative. So it really doesn't matter which leg you want to go with for our general formula. So someone give me one of my two legs of this right triangle. So AB. All right, we're going to go with AB. AB, I'm going to highlight that. AB is my leg. Right there's my leg. Okay, so AB, so the measure of the leg is equal to, so is equal to means equal to the geometric mean. So once again, I'm taking the product, square root of a product. Now, what is my product? What are the two things I'm multiplying here?
The geometric mean the hypotenuse and the segment of the hypotenuse.
Okay, so what's the length of my hypotenuse?
AC.
AC, so there's my whole hypotenuse. Now, which portion of the hypotenuse is adjacent to my leg?
80.
80. There you go. And that's what we're doing. We're going to do that all day today. So, here we go. So look at some examples. Which of these, or which of the two theorems we just talked about